Hi, hello everybody. So this is section 21, radical equations, and I'm going to divide this topic into two videos. The first video I'm going to review and go over the simple details about radical equations and the radical itself. We're going to go over 3 examples, and then in the second video I will do all of these unworked examples that is on the workbook. Okay, so let's take a look at the file I have over here. So a radical equation is just any equation, and we'll see an example shortly, that has the radical symbol as you see over here. All right, so and I have a little bit of a revision here, or just a reminder of what we did before. The symbol itself is called the radical. Okay, anything that's inside of the radical, number or variable or variables, it's called the radicand. Okay, radicand. We normally don't refer to it as radicand very often, but that's what it's called. And the number that goes outside of the radical here is called the index. This is very important. The index has to be a number that is an integer, starting with 2. So the index could be 2, could be 3, could be 4, could be 5, could be 6, could be anything. Okay? In the event the index is the number 2, right? We don't have to indicate it. So for example, take a look at these 3 examples here. In this case, I have radical 5, and because there is no index visible, the default is 2. So there's an invisible 2 right there. Any other index I have to specify. So this is an index 3, this is an index 7. So when we have a radical with an index 2, we call it the square root. Index 3, we call the cubic root. And then we have 4th root, 5th root, 6th root. This will be the 7th root, and so on and so forth. The names are not that very important. Possibly maybe, the square root and the cubic root, 2 and 3, that we see most often. All right. So radical, index, and radicand. So it's important. Now, so how do we solve a radical equation? So this is the procedure that you're going to use every time. Number 1, and extremely important, you must do this every single time. You're going to isolate the radical symbol in one side of the equation. Meaning, and you're going to see an example of this, anything other than the radical itself has to go to the other side of the equation. Once the radical is isolated and not before, you're going to raise both sides of the equation to the index. So if the index is 2, you're going to raise both sides of the equation by 2. If the index is 3, you're going to raise both sides of the equation by 3. The index is 7, you're going to raise both sides of the equation by 7. When you do that, the most important thing happens, as you see over here, and let me show you. This index is going to cancel with the number that you raised on the outside, and the answer is going to be the radicand. So in other words, when you do step 2, when you raise both sides of the equation by the index, the radical, the index disappears. That's what we want, right? So 7th root raised by 7, this cancels with the 7 and the radical, and the answer is only the radicand. That's what we want. After you do that, we must check the solution at the end to see if the value that we got actually satisfies the original equation. So this is important. So these are the 4 steps, okay? So you must not forget these 4 steps because they're necessary for the correct solution of our problem. So let's take a look. I'm going to show you 3 examples that are worked in the workbook. You can go back and take a look at them if you want. So notice that in here, we say solve and check. But on the exam, we won't say solve and check. We're just going to say solve the radical equation. And you must remember that for radical equations, you must check. All right. So in this case, step 1 is already done for us, which is isolate the radical, right? It's already isolated on the left side. So step 1 is done for us. It's probably a good idea, you know, when you're solving this, until you get accustomed to, maybe write these 4 steps, or at least the first 2, which is isolate the radical and raise both sides of the equation to the index, so that you remember exactly what you're supposed to do. In this case, the radical is isolated. On the left side, there's nothing other than the radical itself. I'm done. I identified the index as 2. Professor, there's no number 2 there. Yes, I know, but the default is 2. So we're going to raise both sides of the equation by the index, which happens to be 2. When we do that, the next step is cancel the index with the radical and remove it completely from the left side. So the left side is only going to have the radicand, which is 2x plus 1. On the right, you make sure that you square the number 3, which is 9. At this point, all you have to do is solve the remaining equation, which is either going to be a linear equation or a quadratic equation. In this case, it's a linear equation, very easy, right? Minus 1 on both sides, right? Minus 1, minus 1. I get 8, and I get 2x. Divide both sides by 2, and we get 4. This is the answer that we got, but we have to make sure that this is correct. So what do we do? Well, we have to check the solution. Must check in the original, right on this one. So what do we do? So we replace x with 4, right? So here we go, radical 2 times 4 plus 1. And we need to check to see if it's equal to 3 after we take the square root. So a plus 1, 9, square root of 9, 3. Yep, that checks, which means that this is the solution. Okay, so this is all that we have to do, right? Follow these steps. Make sure that at the end, the solution that you have, in this case 3, solves the original equation. All right, so let's say another one. So all of these are on the workbook, or from the workbook. So solve and check again, but you remember that on the exam, we won't say check. You have to remember that. So in this case, again, the radical is isolated. So I don't have to do anything about isolating the radical, but I go immediately to step 2, which again, the index is 2. So we raise both sides of the equation to the index. On the left side, again, the radical will cancel with the 2. I'm left with the radicand, you know, the thing inside of the radical. The right side, I have x squared. Now, this is important because after I've done step 1 and 2, all I have to do is solve the remaining equation, which in this case is a quadratic. So how do we solve a quadratic? Well, the quadratic, we have to isolate all of the terms into one side. So here, the person who solved the problem decided to isolate the equation on the right side, which is okay. But if 0 is equal to this, then this is equal to 0. And if you want, you can solve x squared minus 2x minus 3, which is equal to 0, which is the same thing. So how do we solve this? Well, we are going to find product and sum, and you know that already, right? Product has to be -3, 1 times -3. Sum has to be -2. And the only 2 numbers that can give me a product of -3, sum of -2. Let's see if we get this. Let's see if this works. 3 times -1 is -3. 3 plus -1 is -2. That's not quite right, right? So then we understand that the minus goes on 3, positive 1. So let's see it again. So -3 times +1 is -3, and -3 plus +1 is -2. All right, so this is correct. And then we can rewrite the middle term using these two elements. So x squared minus 3x plus 1x minus 3 equals 0. We now factor by grouping x minus 3. I'm going to go a little faster here because I'm assuming that you remember this. There's nothing in common with the last two, so we factor a 1. And now we factor the x minus 3. Oops. So x minus 3 is a common factor, and x plus 1 right there. So this is exactly what we have over here. Then by the zero product rule, either this is 0 or this is 0. So in the first case, you add 3 to both sides, and you get x equals to 3. Right? I'll do it here for you to see. All right, so add 3 to both sides. These cancel. Minus 1 on both sides. Okay, so there you go. This is exactly what they got over here. Now we got to check both. And we're going to do it the exact same way as we did before by, in the original equation, we're going to replace 3. And we're going to replace -1 right there. Okay, so here we go. 2 times 3 plus 3. So this is 6 plus 3, 9. Radical 9 is equal to 3, so we're good. The second case, 2 times -1 plus 3, -2 plus 3, radical 1. Radical 1 is 1. But once we replace that -1 here, we get -1. So this is not correct. So the only solution is +3. So if this is a question on the exam, you have to indicate that this doesn't work. If you leave these two solutions, you lose points. So that's why we must check at the end. Sometimes one of the solutions won't work. Sometimes both may not work. So we have to check always. Okay, so this was an interesting case. See another example, the last one for this video is right here. Okay, now in this case, look at the equation. The radical symbol is not isolated. I have this +2 here. So before we begin, we must isolate the radical, and we do that by subtracting 2 from both sides. Okay, these will cancel. I have x minus 2 on the right. Now, at this point, the radical is isolated. Now you can raise both sides of the equation to the index, which in this case is 2. You cannot do it before. So we must isolate radical first. This is very, very important. You cannot forget that. All right, once we do, we square both sides, again, by the index, right? Here's 2, here's 2, here's 2. Now, on the left side, this will cancel with that. I am left with 4x minus 8, which is just the radicand. On the right side, how do we do x minus 2 squared? Well, we double up, right? We've seen this before, and then we foil. Foil this thing. So x times x, x squared, x times -2, -2, -2 times x, -2x, -2 times -2, +4. Combine like terms, this is -4x. So I have x squared minus 4x plus 4. which is exactly what we have over here. And again, I am going to get into a situation where this is a quadratic, and we're going to do it the same way as we did before. I'm not going to repeat it here. You can do it for yourself. But it turns out that we get this product. So we're going to do the exact same way this problem 21.3 as we did the previous one. Apply the zero product rule. Plus 6 on both sides, we get this. Plus 2 on both sides, we get that. We have to check now, right? Must check. So let's take a look at the check. All right, so let's take a look at the check. Okay, where is the check? I don't think I copied the check, but that's okay. I can check it. We'll check it ourselves right here. All right, so this is the original equation. So here is the first check, 6. So radical 4 times 6 minus 8. For the check, you don't have to change anything. All right, you can leave it the way it was. So I have 24 minus 8. All right, so 24 minus 8, 16 plus 2 equals 6. All right, so this is supposed to be 6. Well, radical 16 is 4 plus 2 is 6, so that checks. So the 6, okay. So we're okay with the 6. All right, very good. So let's check the number 2. So again, so I'm going to check x equals 2 now. So 4 times 2 minus 8 plus 2 equals 2. All right, so 4 times 2, 8, minus 8, 0, plus 2 equals 2. Yeah, that also checks. All right, because square root of 0 is 0. So 0 plus 2 is 2. So in this case, both of the solutions work perfectly fine, and you're okay. All right, so this is how you solve these radical equations. Just go back and review these 4 very important steps. Isolate the radical, raise both sides of the equation to the index, solve the remaining equation, which is either going to be a linear or quadratic, and check the solution at the end. Sometimes the solution works, sometimes it doesn't. And if it doesn't, we have to eliminate the one that does not. Okay, so in the next video, we're going to do the remaining problems on the workbook.